Okay, this is a short video on my setup to grind the spindle nose taper of this little Schaublin 70 I've been reconditioning. I guess I'd say I don't think that you have to regrind spindle noses for every machine tool you touch. If the spindle nose taper is in great shape, on a high quality machine tool, the factory ground the spindle nose once it was mounted in the bearings, and there should be perfect concentricity between the bearing surfaces and the taper. However, they do get dinged and bent, and or not bent, but dinged and bumped and bruised over time. And in this case, obviously, I reground the OD of the bearing surfaces, so I really have no guarantee. While I was careful, I have no guarantee that there's perfect concentricity between that spindle nose taper and the OD. So I'm just going to kiss it. I'm getting maybe half a thou, about 4/10 total indicated run out with this spindle right now. And I want to get that as close to perfect as I can. So I'm just going to give it the lightest kiss. The setup that I've used here is to mount the bed on my horizontal mill table. There's absolutely no milling involved, but it's kind of a convenient reference in that if I indicate this surface of the bed parallel with the mill, and then this part over here, which I'm going to use to carry the grinder, put a sine bar in there to 15 degrees and indicate that in, I've now got this oriented correctly to this to grind the right taper. The spindle is being powered by a little console motor that you see back there. I just quickly made up a round belt. Obviously the lathe is designed for a flat belt, but the round belt will suffice for the very low force this grinding operation represents. And yeah, so that's all clamped to the table. The grinder is a mini mill XY table that I scraped many years ago, and this is actually the first time I've used it. I worked very hard to get it to perfection. I know that this front surface here is within 1/10 parallel to the motion of the table. I have got set up in the back the lathe carriage stop from my Dean Smith and Grace, and that's how I'm going to infeed the table in this direction. And on this side of the table, I've clamped a parallel with some die springs in there just to create a bit of preload so that there's going to be no slop in that axis. This should let me kind of control the depth of cut fairly solidly. On the spindle is mounted a small air pencil grinder, and the last thing I have to do here is figure out how to rig a way to dress. I'm going to put a new fine wheel in there, and how to dress it. I have to rig something here to dress it. That'll be the last part of the setup. That's all mounted in square to the XYZ table. And then I pulled parts off of an old, I think it's a Myford lever action cross slide, because I wanted to have a way to control the feed. And if I do this, that gives you an idea. Now I'm going to use a longer bar so that I have more control. My idea here is that I wanted to have the gibs fairly tight, but I wanted to have enough leverage that I'm not suffering sort of a stop and go stiction type of environment. So that's the setup. The other aspect to mention of this setup is that it's really important whenever you're doing any taper work, turning or grinding, that the axis of the cutting tool be on center height. So in this case, it means the axis of the grinding spindle has to be dead on the center height of the spindle. So how I did that was I got things approximately to the right height by blocking them. You can see the base is resting on a parallel. And then when it was really close, I used a height gauge and an indicator, measuring off of each spindle, and then shimmed the lathe bed until it was dead on. So I'm as close as I can get here. It's about a half a thou. You know, maybe it's within half a thou, I think, based upon indicating it. So I say I think because when you start to get into an older mill table this long, there's no way of knowing, you know, how accurate it is 100%. But I think that I've got things within about a half a thou, which should be good. And yeah, so that's the setup. You have to get the cutting tool at the same height of the spindle, and I did so by shimming the lathe bed until, with an indicator on a height gauge, taking into account the difference in diameters, of course, I put a 1/4 inch pin here and measured there to there, did the math, and shimmed till it was spot on. I'm just gearing up here to dress this little point in this air spindle. I made a little block, a very simple thing that holds a diamond dresser, single point dresser. And you know, one of the advantages of decades of collecting every tool you see is you end up with a pile of stuff. So I was able to do the setup because I had this nice little Eclipse mag chuck. I moved the headstock back, put the mag chuck on, and it's holding things ready to dress. Obviously, you always want to dress a grinding wheel before you use it, both to expose fresh, sharp bits of grit, but also to balance it, because it's the best way to ensure that the OD is running true to the axis of the spindle, etc. And you don't usually dress grinding points. I mean, you pop them in a die grinder and away you go. But because this is a high precision operation, I want to dress this little point both to make sure that it's going to cut really, really well, but also to make sure that if there's any eccentricity between the outside surface of this wheel or point and the spindle axis, it's removed, and that should improve balance, reduce vibration, etc. So that's the theory. I've also put some paper towel around the mill spindle and around the headstock of the lathe. A lot of people think that when you're grinding that it's really catastrophic with all the grit going everywhere, and the fact of the matter is there's not much grit that comes off during the grinding process. However, where you do create a lot of grit, and it goes everywhere, is in the wheel dressing process. So I just wanted to cover up those important bits of tooling so that they don't get any invasion of grit settling in them. Okay, I'm going to address this little point now. Things are going to get a bit noisy, and as will inevitably happen, the air compressor will kick on and it'll get really noisy. Okay, we have contact. Oh, didn't have enough juice to get through that dress. Move that back for another tiny little bit of a dress. And again. And again. I'm going to get this so I feel like I've gotten all over the wheel. Not normally how you dress a wheel, of course, but it seems to have worked. So let's I think I'm going to go with that. Okay. Well, that's looking pretty good. There's, if I align my head with the needle so I don't get parallax, there's maybe 3/4 of a tenth total indicated run out. Demonstrating here, pulling up on the spindle, and there's just no movement. So I think I've got a fairly solid, fairly accurate bearing here. I wish I could get it to no tenths run out, but I've been at this a long time, and that seems to be about the best I can get it to. Okay, more tests on this little Schaublin 70. I think I've got the spindle in really good form, and I just want to double check that the spindle is parallel to the horizontal surface of the bed. So what I'm going to do here, and hopefully that indicator is in focus, I'll sweep here. If I do it slowly, you'll see I get just to below the 2. This is a kind of an interesting little indicator. It's a Swiss compact, and it's technically graduated in thous. However, it's really just a tenths indicator without all the lines. For example, from there to there is 1 thou. So it's pretty easy to kind of interpolate the distances between the graduations and get a sense of where we are in tenths. So I'm just under 2 there, and I take it out. I don't want to go right to the end because the end of these pins, sometimes there's some deformation, but if I sweep there, you can see I'm I bumped it. We'll start that again. You can see here if I sweep, I'm right at 1. If I go out here and sweep, I'm right at 1. So I think that's pretty strong confirmation that the headstock is aligned, the axis of the headstock spindle is aligned in this direction with the bed. Now if I rotate the spindle 180 degrees, that's the test to see if perhaps I'm getting a false reading that the spindle is out, but that the pin and the collet is also out. So if I rotate it 180 degrees, do that test again. That's 180 degrees. I'll sweep in here. Again, get 1. And sweeping out here. Again, get 1. So that spindle's looking pretty darn good to me. Now the next thing we have to do is do a test to see how we are in this direction, which is registers the lip on the headstock here registers on the front of the bed, which is of course scraped true and straight and square to this surface. So that'll be the next test, but I'm thinking this headstock's looking pretty good. The other test, I always like to do on a headstock, is just to make sure we don't have a lot of slop. Hopefully that indicator is still in focus. So if I put a little upwards force here, you can see I'm moving it about a tenth. That's not too bad. I think that's pretty good. I could tighten, as it feels a little bit loose here, I could tighten up this thrust situation slightly and see what I get. Let me do that. I made just the tiniest little tightening adjustment to the thrust arrangement. What there is there's a threaded collar that threads onto the spindle and presses the pulley system up against the back of this bronze bearing. There's a plate inside there that's finely finished that is a plain thrust bearing. Anyways, that's a little tighter now. As you can see, I am getting no run out on this spindle whatsoever. It's just absolutely perfect. You can see I'm not at the bottom of the indicator's range or anything, but if I kind of put that on 2 there and rotate, it is just dead on. Well, we got to be happy about that. Now, with this tighten, let me try a little bit of upwards force and see. Yeah, see, I'm not moving that a tenth now. That is just perfectly adjusted. Pressing down, pressing up, pressing down, pressing up. So I'm pretty happy with that. This still turns smoothly. There may be a slight break in, and that might need a bit more adjustment, but boy, it's just looking absolutely dead on. So I need to get things aligned in this direction, or make sure they're aligned in this direction. I had already been working on that, and then just scrape the tailstock into alignment with. Okay, a bit more testing here. I had previously done quite a bit of scraping on the headstock, the tailstock. There's kind of 2 things I want to be, or more than 2 things, but initially the 2 things I'm looking at is making sure that the tailstock quill is aligned with the bed so that that is the same height as that. And then I also want to make sure that the center of this axis is the same height as this axis. The last thing I want to make sure of, and that'll be a next step, is making sure that the tailstock is aligned along the Z-axis properly. So as a first check here, let's have a look at the height of this pin. Make sure I'm getting some focus on the dial there. So we are about 1.5. I'm carefully moving it around and picking up this pin here. We are again dead on 1.5. That's within a tenth or 2. Yeah, really happy with that. Okay, so that's got our tailstock height right on with our spindle. Last thing I have to do on the tailstock is again bring it in this plane, and bring the headstock in this plane. And I don't know, I may have a few other things left to do that I haven't thought of, but I think we're pretty close to going to paint on this, which would be great. I've been at this project a long time.